Boom! Yes, folks, Hume here again. How are you doing? So in this video, we're going to start an exploration of the topic of factorization. That is one of the topics that causes a lot of problems to a lot of people in maths. So what I have attempted to do here is to break down different types of factorization problems that you will tend to get at the level of csec mathematics. Right? I am not too sure what they call it in other jurisdictions, but generally speaking, we're talking about, for the purposes of school, we're talking about people anywhere in the age range from about 13 to 14 straight up to about 15, 16. All right? So basic factorization, because like everything else, we have different levels of difficulty, but once you understand the mechanics of the basic stuff, it puts you on a sound footing to move ahead to the harder stuff. So the first type of question we're going to deal with is what we refer to as the univariate binomial. All right, I am getting as specific as introducing the vocabulary because I want you to understand that there are different types of questions. So we have univariate binomials, then we have bivariate binomials, then we have quadratics. Right? We have factorization by groups. We have difference of two squares. Right? Those are the kinds of groupings we're going to be dealing with. So we're starting with univariate binomials in this video. Univariate because we only have one variable, univariate. One thing whose value could change. And then a binomial meaning that we have two terms in a particular expression. So an example of a univariate binomial would be something like, let me say, 3x plus 12. You have one variable, two numerals, two numbers. Let me say you have 4x, right, minus 28. Again, one variable, only x is the only variable here. And then you have two numerals, two expressions separated by a subtraction sign in this case and an addition sign in this case. Of course, we have other levels of difficulty. So for example, we have something like 9y squared minus 63y. Again, one variable, even though we have y squared here and y here, as opposed to x alone here and x alone here, the idea is that the only variable we're dealing with here is y. Right? And we normally use letters to denote variables. In other words, entities whose value could change. So 9 is a constant, 63 is a constant. Y, however, could take any value. So we refer to that as a variable, right? And because it could take any value, we don't always know what value it could take, so we just denote it as a generic Y. Yeah? Is there any other? Right, that's more or less it. Right? So this is the kind of level of difficulty we're going to be getting into here. So let me start with this guy here. So if I come to you and I say to factorize the expression 3x plus 12, all right, how do we do that? Well, remember, factorization means, as a concept, the process of breaking up something into its constituent factors. In other words, the factors that constitute the thing, the factors that make up the thing, you're breaking it up into that. All right? So, if I have to factorize the number 36, I can say 36 is 4 multiplied by 9. You break it up into two factors, right? The two things that multiply to go together to give it 36. If we have to use an analogy in chemistry, where we have certain chemicals that mix together to form a new compound, right? So if you could break the compound back down into the original constituents, right, we use different vocabulary for that. So for example, if you need to break down water into hydrogen and oxygen, we call that electrolysis. That's a chemical term. In maths, we would call that factorization, right? So the idea is that we're breaking it down into two or more 2 or more. It's not always 2 factors alone. Eh? We're breaking it down into factors that multiply, right? The whole idea of factorization implies multiplication, right? You're breaking it down into stuff that multiply together to get the original thing that you had before. So in other words, if we have 3x plus 12, right? We need to break this down into a product of 2 factors. It might be more, but for now, we start with 2 because we are at the basic level. You're breaking it down into the product of 2 factors, which, when you multiply them by each other, the answer is 3x plus 12. And we usually do that by looking for what we refer to as the common factor across the entire expression. Right? This is pretty straightforward, so I expect most people, even those who claim to have difficulty with the topic, to either get it out before I write the answer on the board, or as soon as I write the answer on the board, perhaps they understand it. But I want you to stick with it. Stay with me here, because it's going to get more difficult as we go along. So we put in the building blocks in place. Right? You have 3x here and you have 12. Common factor, 3. Alright? So, and I wanted to look at this carefully. This is a method that I teach to my students in terms of how you write these factorization questions. How you write stuff is so important in maths. Alright? So basically what we could do, we could put, let me say, we start off with the expression as is. And we have a pair of brackets where something outside the bracket multiplied by something inside the bracket to give you back the original expression that you had here. If we agree that the common factor here is 3, then we take the 3 and we put it outside the bracket. Alright? So we could say, we could say either from a visual inspection that if you take out the 3, you'll be left with x here. Or if you want to get a little more technical in your approach, you could say, well, alright, 3x divided by 3 is equal to x. Or 3 into 3x is equal to x. So in other words, by writing it like this, you have a system that allows you to quickly check your work as you go along. And this is particularly important for the folks who might be having some problems with it and you might be having to go a little slow at the beginning. Maybe a table is not so hot, right? So when we get to 6 timetables and 7 timetables and 9 timetables and 8 timetables, you ain't really sure if 9 by 6 is 54 or 63. Or if 9 by 7 is 63 or 81 or 72. Yeah, these are the things that make things a little slower for us. But I'm trying to put a system in place here that allows us to not have to guess. Right? So, right? 3 into x, 3 into 3x is x, 3 by x is 3x. You could double check as you're going along. And then you 4 here. If 3 is the common factor, then 3 into 12 is 4. And then you have your plus sign there. So your final answer is 3 into x plus 4. Now, of course, as you go along, you'll find that you could do this one time by sight. Right? You see 3x plus 12. Right? Bam! You know immediately that the answer is 3 into x plus 4. But I am trying my best to put something in place so that if you're still here, you could develop a system so that you go slow at first and then you develop the speed so that eventually you come here, braps, and you run through it. Alright? Nice. So that's the first one. Let me go to the second one here now. The second question along this level of difficulty, right? We're going to change the sign now. So in this first one, we had 2 positive signs. We had plus 3x and we had plus 12. In the second one here, we start to switch it up now. So you start to see the different types of expressions that you're likely to face when you have to deal with factorization as a topic at all levels. All right? So if you have to factorize 4x minus 28. This time you have a plus here in front of 4x and a minus in front of 28. Again, you're looking for the common factor. So you know your 4 time tables, no problem. 428 is 7. But let us assume for the sake of argument that your 4 time table is not so hot. Maybe you're in a paper 2 and you have the calculator as something that you could use to help you factorize. Yeah? So you put the brackets here. Once you figure out that 4 is the common factor, you can say, well, all right. You take the 4 and then put it outside. 4 into 4x is x, and 4 into 20 is 7, but we have to consider the minus sign. So 4 into minus 28 is minus 7. So your answer here is 4 into x minus 7. Let us, for the sake of argument, say that, okay, you see 4x and you see minus 28. And instead of going for the 4, you go for the 2. So you recognize that you're dealing with 2 even numbers, and just for the sake of safety, you say, well, all right, let me take out 2 as the common factor. That is something that a lot of students do in the early stages when they're now getting into it. So you find that they wouldn't go rushing to divide by 6, or to divide by 8, or to divide by 4, or to divide by 10. Sometimes they latch on to 2 as a safe factor where you could see the result faster. And that is something that I want to recommend to folks, right? You're having problems with factorization? All right. Nobody's saying you have to jump to go and divide by 14, right? So for example, if I have 14p minus 56, you mightn't necessarily know that 14 by 4 is 56, right? So here what you do, you say, all right, same system we're employing here. You take out 2 as your first option. 2 into 14 is 7p. 2 into 56 is minus 28. And then you look inside the bracket. You see? So we're introducing different steps now. And I'll reinforce it by going back here. So you look inside here now and you say, well, all right. You have 7 here and you have 28 here. So we still have a factor that we could take out. And you take out the 7 and then multiply by 2. So you see 2 here in brackets by 7 here. Big brackets here now. 7 into 7p is p. 7 into minus 28 is 4. Right? So now you would have here 14 into p minus 4 as the answer. So you could run from here to here in one step, which you will get to once you stay with the program. Or you could say, well, all right, I didn't see 14 as the first factor. I saw 2 as the first factor. So I take out the 2. You get 2 into 7p minus 28. You look in here and you realize, well, all right, I have a 7 here still that we could use as a factor. You take out the 7 and you multiply it by the 2 that is already outside. So 7 by 2 is 14 on the outside. And then you do your division. 7 into 7p is p. 7 into minus 28 is minus 4. 2 by 7 is 14. 14 into p minus 4. That's the answer. So it's not about speed. We're not going a race. There are folks who will get here in one line. There are folks who will need to go through 2 or 3 lines to get to the same answer. There's no prize for reaching the answer first. Right? The only prize is the prize for getting it correct. So feel free to go slow in the beginning, and eventually you will develop your own natural speed and rhythm that will serve you in your own stead whenever you need it. Right, so back to our good friend here. Right? So let us do over the same question where instead of taking out the 4, let us assume for the sake of argument that just as we did here in red, we didn't recognize that 4 is a factor of 28. But you look at 4x and you look at minus 28 and you say, aha, we have 2 even numbers here. So the numbers being even, we know immediately that 2 would be a common factor to both of them. So here what we do. We take out the 2. You say, all right, 2 is a common factor. 2 into 4x is 2x. 2 into minus 28 is minus 14. Beautiful. Except that now we're looking inside the brackets and you realize, but wait, it have 2x in there and it have minus 14 here. Both of which are even. So in other words, it have a next 2 that we could take out. Right? Which brings up the topic of what we refer to as complete factorization. So in other words, in your past papers, you will see very often an instruction to factorize completely. And a lot of factorization questions come like that, where it is possible to factorize, but you ain't finished yet. You have more things to do. This is a simple example that we work in here. So in other words, in this case, if you factorize this and you stop here, you're not going to get the full marks if the question required a complete factorization, which is usually the case. So if this question is 2 marks, you lost a whole mark for not finishing the factorization. Alright? If it was 3 marks, you would probably get 1.5 or 2, depending on the marking scheme. Alright? So when you're going through this system to factorize, what you want to do is look inside the bracket at every step to see if there is any possibility of further factorization. And you only stop at the point when there is no further possibility of factorization. In other words, where the expression inside the bracket cannot be factorized any further. Cannot be broken down then, so to speak. So in this case, we have 2 as a common factor still, so watch. 2, and I'm introducing you to another form of notation now. Let me say you have 2.2. This is another way of writing multiplication. This is not 2.2. This is 2.2 multiplied. 2 into 2x is x. 2 into minus 14 is minus 7. So 2.2, now we could come and put 4 here into x minus 7. So 1, 2, 3, 3 lines, or maybe, as we did a little while ago, you might do the same question and realize that, hey, 4 is a common factor, and you take out 4, and you get it in 1 line. 3 lines, 1 line, no difference, once you end up at the same location. All right, so we put a system here for the folks who need the extra working. And if you happen to be in that category, there is no shame in the game. Every single human being on earth will at some point in their life find themselves in a situation where they're trying to learn something and it's taking them a little longer to figure out than it's taking the man next to them or the woman next to them. No shame in the game. We wouldn't be the fastest person off the blocks in every single situation, right? Yeah. So if maths is one of your situations where, yeah boy, pressure, taking long to figure this thing out, no problem, no problem. Just take your time. Just take your time. One step at a time, spend enough time with it, stay with it, and you will figure it out. Once you give it the time and attention that is required. You must give it time, and you must give it attention, and you must give it focus. Whether you're in a Zoom class, or a face-to-face class, or you're working on your own, or somebody helping you. The one constant that runs through all of those situations is time, focus, and attention. You must give it that. Alright? So we're putting something in place for somebody to work on their own, and if you have to get somebody to help you, no problem. Right. So that is one set, 2 sets. So we're going to do our next variation now where the factorization is concerned. So we're going back to the same 3x plus 12 that we had at the start. This time, however, what we're going to do is switch up the signs again, because as you will see, the signs are a big factor. There are people who could factorize smoothly when everything is positive. The minute you introduce a negative sign, pressure, right? So we need to be as comfortable with the negative signs as we are with the positive signs. That is one of your foundation building blocks. In any kind of maths, at any level, you must be comfortable using your negative sign. Right? So we're going again. So if I have to factorize, let us say, watch it now, minus 3x plus 12. Aha! Discussion going to get nice now. And I want you to pay particular attention to what I'm going to see here. All right? So you look at minus 3x and you look at plus 12. You realize, well, all right, we have a 3 and we have a 12. So 3 is a factor, no problem. So you could do this. You put the brackets as we explained earlier on. And you say, well, all right, 3 into minus x plus 4. No problem. 3 into 3x is not x, which I have seen students do in my class. They go through that whole thing as if the minus sign wasn't there. Right? 3 into minus 3x is minus x. 3 into 12 is 4. Right? Most people will stop here because we take out the 3. And you look inside the brackets and it really have no factors in there to factorize. And while that is very correct, technically, I want to take some time to explain something that I have had to explain with students in my own class, where the factorization is concerned with the negative numbers. And it goes as follows. In a situation like this, where you take out your common factor and you have a negative sign in the first term inside the brackets, the convention that we use, the mathematical convention, is that we don't ever have the first term inside the brackets with a negative sign in front of it. This is one of those unwritten rules that people sometimes don't really be conscious of, but it is there. And it serves a purpose, as I had to explain in one of my classes at some point when we were dealing with factorization by groups. But that's a different conversation. But suffice it to say, and I want you to take it as this, this is not something you want to be doing when you're factorizing an expression like this, where you have a negative sign in the first term. Do not leave this as your factorization. Mathematically and technically it is correct. But from a point of view of utility, your ability to use it in other mathematical circumstances, this is not going to help you. But we will explain that in other places, another time, and another day. So the convention is that we don't leave negative signs in front of their first term. So there are two options we have. One option is we can write the answer as 3 into 4 minus x. We could do that. We just change the order. Alright? But it's the same thing. Minus x plus 4 is the same thing as 4 minus x. Alright? Or, what we can do, if we want to maintain the x in front here, and there are circumstances where that is exactly what we want to do, we can take minus 1 as a factor out here. So in other words, we could factorize by taking minus 1 as a common factor. That is one of the tricks that a lot of people probably don't get sometimes. But the ability to factorize where you're taking minus 1 out is a huge, huge skill in maths. So the ability to divide by minus 1 and the ability to multiply by minus 1, which in truth and in fact, from a point of view of the result, is the same thing. Right? It's like multiplying by 1 and dividing by 1. No real practical difference. The same thing happens with minus 1. You multiply by minus 1 or you divide by minus 1, more or less is the same thing. Right? But the ability to recognize that, hey, I could divide by minus 1 here, or I could multiply by minus 1 here. The ability to do that in maths, very, very, very important skill. And all of that, we set the questions up. My questions are this, but you could find questions in other places. My questions are set up where you're getting the chance to practice these things, and that is what I'm doing here in terms of explaining. So that now you get to practice. If you're using my questions, no problem. If you're using other questions, you'll meet it at some point. Right? So you take minus 1 out, you divide by minus 1, which means that you're taking minus 1 out as a common factor. So this will be minus 1. Let me put the minus 1 in brackets. You don't ever leave a minus sign exposed. Right? That is another convention in maths. Do not. You try your best, sorry. I wouldn't say you don't ever, because you will see an exposed minus sign just now. But in a case like this, yeah. These are the things that you'll pick up as you go along. So pay attention. Minus 1 dot 3 multiply by. If you divide by minus 1, it means that you're changing the signs of all the terms inside the bracket. Or you could check it out by saying, sorry, let me write this over. We need to put the, hold on. We had 3 here, so what we do, we put the 3 a little further out, and we bring the minus 1 here. That way, you get to see everything close up. Alright? So minus 1 is a new factor, so that is the one closest to the bracket. Minus 1 divided, minus 1 into minus x, which is another way of saying minus x divided by minus 1 will give you x. Minus 1 into plus 4 is minus 4, or we could say 4 divided by minus 1 is minus 4. So 3 by minus 1 by x minus 4. Now we could say minus 3 into x minus 4. This is where we want to end up when you have a situation like this. We don't leave it like this. And even though this is an acceptable version of this, it is better to go here, because if you find yourself in a situation where you have to use this result later on in the same question, part B, this might be answer in part B and you have to use that in part C, or you have to go further down in part B with this. This is what will carry you further. This wouldn't really help you. Alright? So you're getting everything, which is why you have to give it time, focus, and attention. Alright? Nice. So that is that part here. So let me go with the next one now. Minus 4x minus 28. So you realize that I'm using the same numbers, I'm just making very slight changes to the expressions. And the reason why I'm doing that is because I want you to see the effect of slight changes to your process and to your result. Do not, under any circumstance, make the mistake of thinking that if you factorize 4x plus 28, you'll get the same answer as if you factorize 4x minus 28. And if you get the, and if you do that, if you factorize 4x minus 28, you'll get the same answer as if you factorize minus 4x minus 28 or minus 4x plus 28. See what I did there? One pair of terms. 4 possibilities. Plus plus, plus minus, minus minus, minus plus. Each one of these will give you a different result. Sometimes the process is very, very different. You have to appreciate that small changes in a mathematical expression could trigger a significant shift in your process, in your procedure, and sometimes even in the result. And a lot of things in life like that. A small change could trigger a big result elsewhere. They call it the butterfly effect in philosophy or whatever, where I forget the exact description. Let me check and see what the Google is saying. Yeah, the butterfly effect. Let me see, boy. Philosophy is part of the maths, you know. Philosophy is maths and maths is philosophy, all this city. The butterfly effect. I'm showing all how maths is connected to life. Maths is life and life is maths. Don't ever forget that. Alright? The butterfly effect. Butterfly effect. It was a film and all that. Right. The butterfly effect is the idea that something small, like getting coffee, can have a much larger effect, such as altering your career, blah, 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 blah. Right? Hold on. I think the butterfly effect is named for some kind of situation where a butterfly flapping its wings in one part of the country could have an effect on the wind systems and the breeze, and as a result of that, the weather somewhere else in another part of the country. Everything connected. So in maths, sometimes you just change the sign. Whew! And there's a whole one set of different changes there. So take your time and listen to these things. I want you guys to understand the philosophy behind the maths. Don't jump in and just want to look at the figures. There's a philosophy behind the thing. Right. So with that in mind, we're going to minus 4x minus 28. That's what we're looking to factorize now. Right? So if I have to factorize minus 4x minus 20, just as we had before there, you realize that you have a minus sign in front of the first term. So generally speaking, if you have some terms with a minus sign in front, there is a chance that when you factorize, your final answer will also have a minus sign in front of it. I want you all to get accustomed to the different permutations, different arrangements, the different types of questions, so that you start to get comfortable now. And then you can move on to harder stuff. So let me go here. You can take out the 2, you can take out the 4. We used the same numbers before, so I'll just go straight to the 4 here. So you can take out the 4 as a common factor, because the main thing we're looking at here is the minus sign. Right? You take out the 4, and you end up with 4 into minus 4x is minus x. 4 into minus 28 is minus 7. You realize that you have minus x minus 7 here, and just as we discussed a little while ago, we don't want to leave this as minus x. Now, unlike the last term, where we had the option of just switching the order to get the minus sign behind, so it was 4 minus x. So it was minus 3, it was 3 into minus x plus 4. And we had the option of saying 3 into 4 minus x. You realize you don't have the option here. Even if we change order, you'll end up with 4 into minus 7 minus x. See? So you have a situation now where simply reversing the order is not going to offer any assistance at all. So it just drives home the point even more firmly that A, we need to do something different, right? And that something different, as we explained a little while ago, is to take minus 1 out as a factor from this. So the same way we could take out 2 as a common factor, or 3 as a common factor, or 4 as a common factor, we can also take out minus 1 as a common factor when we're doing these things. Right? So, in this case, and I'm doing it slow so that everybody could have a chance to pick it up. You already have the forward side, right? Dot, minus 1, minus 1 into minus x is x, minus 1 into minus 7 is plus 7. Right? So now we have x in front here, and we have plus 7 here. But the main thing we're looking for is the plus here, right? But we have plus 7 too, no problem, right? Remember, anytime you divide by minus 1, you change the sign of everything. All the terms in the expression. Same goes for when you're multiplying by minus 1. 4 multiplied by minus 1 is minus 4 into x plus 7. Boom! Question done. Again, you may be able to jump from here to here in one line. That is beautiful. You may be there already, or you might need a little time to get there, no problem. But in the interim, what I am putting down here is a system where you could take your time and arrive at the correct answer. Do not feel pressured to get to the answer in one line, which I see students do so often. They get a factorization question. It's not even a simple question. It might be one of those questions with 2 variables and all this kind of thing. And they feel that they have to write the answer in one line. Nothing could be further from the truth. If you're not there, you're not there, and that is okay. We all have moments where we're a little slow at catching something, and that is fine. Most cases are cases where if you spend enough time with it and you give it the focus and attention that it needs, the speed will pick up. And then before you know it, perhaps you're solving all kind of complicated factorization question in one line. But you cannot rush or hurry that process. You have to go through the process of going through it slow, making sure you understand the dynamics behind it, and then bam! Before you know it, speed. Right? Nice. So we're going again. So we're going to get a little more complicated now. Right? So the first 4 were questions where you had one variable, but the variable was only interacting with an integer or a number. What about if the variable interacting with itself? Remember, it is a univariate or univariate, so there's only one variable. So the only other variable that it could be interacting with is itself. We will get to questions soon enough where we have 2 variables. You have 2 variables interacting with each other. X, Y, or PQ, or W squared, V, or Y squared, Z squared. You have 2 variables interacting with each other. But we will get to that shortly. For now, we're dealing with one variable interacting with itself by multiplication. Right? So let us say we have a question, and the question is, you want to factorize 6y squared. I need some more space here, boy. Hold on. You need to factorize 6y squared plus 42y. Right? Right. Now again, you might look at this immediately and say, well, hey, 6 into 42 is 7. Yeah, you could do that. Or you could say, all right, 3 into 6, 3 into 42. A lot of people wouldn't look at 42 and know that 42 is 3 by 14, right? So they might go with the 2. So let me go with the 2 for the sake of simplicity, for the sake of instruction. Let me go with the 2 because 6 is even and 42 is even, right? So you say, all right, 6 and 42. So you put the brackets as we discussed a while ago, and you put 2. You say, 2 has to be a common factor. 2 into 6y squared is 3y squared 2 into 42y is 21y. Now inside the brackets, you suddenly have numbers that you could see, well, all right. You could see a connection faster. So in other words, you could see the connection more rapidly between 3 and 21 than you might be able to between 6 and 42. You see the same connection. 3 by 7 is 21, 6 by 7 is 42. But a lot of people don't know that 6 by 7 is 42. But most of them know that 3 by 7 is 21. So you get in here and you realize, yeah boy, 3 and 21. So here we're going to do. You realize 3 is a common factor, so you take out the 3. Alright, so you have 2 that you already had out here. You have 3 here. So 3 into 3y squared is y squared. And 3 into 21y is 7y. Aha! So as far as the numerals are concerned, we exhausted y squared and 7y. However, where the variables are concerned, different story. Right? Because you have y squared here and you have y here. Right? So you're factorizing here as well. Because you could easily get a separate question. Somebody could come and tell you, factorize y squared plus 7y. And you take out the y into y squared is y. You take it back the other way, y by y is y squared, plus y into 7y is 7, y by 7 is 7y. Right? So in other words, if I have to factorize this, then this is the answer. Which means, therefore, that if the same y squared plus 7y is here, I can take the y out as a common factor as I did here and continue with the working. So in other words, this here is not a complete factorization. Alright? So you now have 2 by 3 by the most recent factor, which is the y. Y into y squared is y. Y into 7y is 7. Right? Same thing we just got here. And now you bring it all together. 2 by 3 by y is 6y. So your final answer is 6y into y plus 7. Yeah? Right. Now, of course, as the factors and the numbers get bigger, you'll realize that there are different ways to factorize. So if 4 is a common factor, it only have 2 ways to factorize that. You can either take out the 4 one time, or you could take out the 2 and then take out the other 2. 2 by 2 is 4. If your common factor is 6, you could take out the 2 first, you could take out the 3 first, or you could take out the 6 first, depending on whichever one you see first. If your common factor is 12, you could take out the 2 first, you could take out the 3 first, you could take out the 4 first, you could take out the 6 first, or you could take out the 12 first. It all depends on which you see. And in other words, if I have 4 people in a room and I ask them to factorize 24w squared minus 156w. Twelve is a common factor in both of these numbers. Right? But most people wouldn't see that 12 is a factor of 156. They will see that 2 is a factor here and 2 is a factor here. Maybe somebody might see 3, maybe somebody might see 4, maybe somebody might see 6. And there may be people who would see 12. The point I'm making is that each of the 4 people in that room can do the factorization differently. So if you're copying, you better be sure that the person you're copying from doing it correctly. Because if you look across here and you see somebody take out 6 as a common factor, and then you look across here and you see somebody take out 4 as a common factor, the first factor that is, at that point, it's either you're guessing who to listen to, who to go with, or you're then going to take a decision as to which person you trust more. It's a different conversation. That is not even maths at that point. Right? That's about humans and human interaction. The point I'm making is, you learn it how you learn it. If you want to go with the 2, go with the 2. Eventually you'll get to the point where you see this and you realize, all right, 12 is a common factor. Right? Or you see this and you say, aha, 6 and 42, bram, 6 is a common factor. And while you're doing that, you see y squared here and you see 42y. You say, aha, y is a common factor. So there are people who, upon seeing this question, will do the answer, will write this. 6y into y plus 7. No problem. Perhaps. And then there are others who, on seeing the same question, they will say, all right, we take out the 6 and you have y squared plus 7y. And then you take out the 7. So 6 by 7, I'm putting it here. 6 by 7 into, no, sorry, not 6 by 7. 6 by y. 6 by y into y plus 7. So you take out the y, you take out the 6, and then you take out the y. And then you say, well, all right, 6y into y plus 7. Right? Different ways of doing it. So don't ever labor under the misconception that if you're doing a question or if you're doing a particular type of question, there is only one way to do it. There may be situations where that is the case, but that is usually the exception. In most situations in maths, there is usually more than one way to work a particular question. And if your teacher is a teacher that is forcing you to go down one particular channel that they like or that they are comfortable with, then I would respectfully suggest that you need to watch that teacher cookie eye, as we say in Trini lingo. Right? And if you are a teacher and you're doing that, then I would respectfully suggest that that is not the best way to go, because maths is a broad thing. It's nice, right? And you want to be able to embrace and identify with different ways of solving the same question, which would then open the door to each individual student to express the thing in their own unique way. As I tell my students all the time, write it however you want to write it. 1, want it neat and legible. 2, once it is making mathematical sense. It is correct mathematically. And once you get the correct answer. 3 people could do the same question. 3 people could employ 3 different procedures. And if they apply the different procedures with correct mathematics, they will all get the same answer. That is one of the beauties about maths. It is like driving to go to a particular location where there are 3 different routes. Right? So you might know the 3 different routes as a driver, or you might be sure, so you're going to your Google Maps, perhaps, and there's a thing in the Google Maps where they say calculating best route. Right? So you might get a different route depending on the time of the day, depending on whether route 1 has traffic. They might put you on route 2. Another time they might put you back on route 1, and then there may be another time when they'll put you on route 3. Sometimes you drive in and you get lost, and the routes would change and adjust with your location. So as your location changes, your route adjusts, but you're ending up in the same direction. So by all means, express yourself. Express yourself, but do it correctly. If you're expressing yourself mathematically, you have to follow the mathematical rules. Right? Yeah, there's no negotiation, there's no debate on the fundamentals, the rules. But even within that, you still have room for self-expression. All right, so we're going again. So we getting the idea, right? Right, so we went through the different ways in which you could do it. So let me start our next one now. Right, so again, we're still on the univariate binomials, right? All the expressions we're looking at in this segment, there will only be two terms in the expression. The two terms will carry their own sign, either positive or negative. And both of the terms will be separated by one operation, either addition or subtraction. All right? And once you develop competence there, you could get to a trinomial. Now you have three terms now. So instead of 3x plus 12, you could have, let me say, 3x squared plus 12x minus 14. Not 14, minus 15. Right? Where the answer is 3 into x squared plus 4x minus 5. Once you develop these skills with two terms, you could then add. You could then express the same techniques and the same knowledge and the same skills when you have three terms. That's another one of the beauties of maths. You learn it in a small box, and then you just increase the size of the box. And you use the same procedures, the same ideas, the same techniques, and before you know it, you're solving all kind of hard things that you didn't think you could have done before. But as I said a while ago, time, focus, and attention must. Alright? Nice. So let me get to the home stretch now in this segment. Yeah? So next set of questions. So let me say we have to factorize 9y squared minus 63y. Right? So you see now where your tables enter the picture. Because you get an expression like this, you see 9y squared and you see 63y, you say, I ain't really sure. Now in a paper 2, you might have the calculator. And you can say, all right, I wonder if 9 is a factor of 63, boy. And you try it and you see, perhaps 9, 7 or 63. Or, let me say you just choose to use 3 as a common factor. Because you see the 9 here and you see a 6 here and a 3 here. So if this number is 63, then 3 has to be a factor. It makes sense, right? So let me use 3 as the common factor. So you take the 3 out here. And you have 3 into 9y squared is 3y squared. 3 into minus 63y is minus 21y. Right? No problem. You have a 3 here and you have a 21 here, and minus 21. So we're going again. 3 is the latest factor now. 3 into 3y squared is y squared. 3 into minus 21 is minus 7y. So we're going again. You have y squared here and you have minus 7y. So, as we explained a little while ago, you take out the y as the common factor. No problem. So you have 3 by 3 by y, most common factor, most recent factor. Y into y squared is y. Y into minus 7y is minus 7. So you then have now 9y into y minus 7. 3 by 3 by y. Right? Or, you could do like some of you. You see 9, you see 63, you say, aha! 9 into y squared minus 7y. And then the next line is 9y into y minus 7. Right? Or, you could do like some others of us. You see this thing there, they say, hey, yeah man, 9y squared, 63y. You see here, 9y is a common factor, bram, bram, bram. So your first line, 9y into y minus 7. If you're doing this where you're getting the answer in one line, you better make sure that what you're doing is correct. because you don't want to lose marks here because you was trying to show off to yourself. Or maybe to the examiner that you could do it in one line. Or maybe you were just plain lazy. You don't want to go through all of that. So here what? Perhaps, let me try it in one line. If you're trying it in one line, know what you're doing. If you have any reason whatsoever to not be sure, we have a system in place where you could take your time and get it done. It's like learning to drive. If you're now learning to drive, you don't go looking to drive at 100 kilometers per hour. You take your time and make sure you can handle a vehicle at 40 first. Because 40 kilometers in the hands of an experienced driver is a very different, well, 40 kilometers per hour, sorry. 40 kilometers per hour in the hands of an experienced driver is a totally different 40 kilometers per hour in the hands of a novice. Maybe somebody who now manipulating a vehicle for the first time. It's not the same. The speed is the same. But the experience, the movement in the car, totally different. It's not the same. Right? So, if you see somebody running on the road at 100 and you now learn to drive, you take your time, brother man. Take your time. Go to 40, then you get comfortable at 60, then you get comfortable at 80, and then bram! Before you know it, you're zinging on the highway at 120, looking to see if police there. Because you want to move from 120 to 140 because you're the best driver. No! Right? But take your time now. Don't rush. So in other words, you don't have to go here if you ain't ready for that yet. No shame in the game. We have a system. 1 line, 2 line, 3 line, 4 lines. You have an option. 1 line, 2 lines, you have another option. And then perhaps, eventually you'll get to the point where you can do it in 1 line. Right, so we on the home stretch here now. Same basic terms, but we're making slight changes in the expressions as we did before. So instead of 6y squared plus 42y, what do? We have here yeah boy, papa, your mama. We have here minus 6y squared plus 42y. No problem. So you see the thing change already because we have a minus sign in front of the 6y squared. So, just as we did, we're taking it slow and we're building it up. Just as we did, let me say we see 2 as the common factor again. So you take out the 2. 2 into minus 6y squared is minus 3y squared. 2 into 42y is 21y. Right? Minus 3 plus 21. You see the 3 as the common factor, no problem. So you take out the 3. 2 multiplied by 3 into 3 into minus 3y squared is minus y squared. Very careful with your signs. Don't make the mistake of saying that 3 into minus 3y squared is y squared. A lot of folks will make that mistake and cause problems here. Remember, these small mistakes will hurt you lower down if you're using a result up here to work out a sum down there. Alright? So be careful with your signs. Alright? Right, and 3 into plus 21y is plus 7y. But as we discussed previously, we don't want to leave minus 7 in front of the y squared if y squared is the first term. So what do? We take out minus 1 as a factor. So you now have 2 by 3 by minus 1. Minus 1 into minus y squared is plus y squared. Minus 1 into plus 7y is minus 7y. But we ain't finished yet. Because, hold on, I'm trying to do this thing in a nice way. We ain't finished yet because you have y squared and you have 7y. So what we do, right? Minus 2 by 3 is 6. 6 by minus 1 is minus 6. So let me say minus 6. So let me say minus 6 by y. Remember, we're putting the minus 6 in brackets, right? We're not negotiating that at all. Minus 6 by y into y squared is y. Y into minus 7y is minus 7. Braps. So now, as your final answer, you have minus 6y into y minus 7. Alright? End of discussion. You see we have the minus 6y on the outside, we have the plus y here, and we change the signs here as opposed to what we had when we were over there. And again, as we discussed, you could either run it through with the 2 and then the 2 by 3 and then the 2 by 3 by the minus 1, or you could say, well, alright, we're taking out the 6. So 6 into 6 here into minus y squared plus 7y, and then you take out the y or the minus 1. In other words, once you start to do the thing, you'll realize that it have different ways of doing the thing. And you could change your method depending on the question that you're working. And that is why I'm taking the pain sometimes here to work it in different ways so that you see the different possibilities. And I'm just giving you one way to work it. That's why the video is so long. But if you're serious about factorization, the length of my video will not be a problem. The length of my video will actually be something that you would welcome as somebody taking the time and the effort to go through the details and the complexity of one of the topics that causes trouble to a lot of different people in maths. So stay in the game, right? Right, so you take out the 6 and you realize, well, all right, you have a y squared and a y. So you say, well, all right, I'll leave in the minus sign for last, so you notice that. So you have 6y into minus, y into minus y squared is minus y plus 7, right? You could put the 7 in front of the y, but that ain't really helping you. So here what we do, we multiply by minus 1. So you have minus 6y. The signs here will change. Minus 1 by minus y will give you plus y. Well, divided by, yeah. Minus 1 into minus y will give you plus y, and minus 1 into plus 7 will give you minus 7. Just as we explained a while ago. Right? You can do it like that, and of course, there are folks who will just see, hey, minus 6y squared plus 42y. They do that. Bram, minus 6y into y minus 7. That people will do that. If you're not there, then you have this option and you have this option. You can take out the 3 as a common factor if you want to, as the first factor, sorry, no problem. Right? Let me say for the sake of argument, they took out the 3. Just for the sake of argument, right? Yeah, because different people see the thing differently. You'll be surprised. You'll be in a class with 12 people and everybody else taking out 2 as a common factor. And then one student in the corner will say, sir, well, I do the same question and I get the same answer, but I use 3 as my common factor. That's wrong or correct? As my first factor, sorry. That's wrong or correct? And then I'll have to say, well, no, nothing wrong with that. That's perfect. It's just different to what the other 11 students do. But it's perfect. And again, that's another opportunity now to mention another one of the life lessons that I like to teach while I teach it, which is 12 people might be in a room. And sometimes one person do the thing different to all the 11, 12. But if it's maths we're talking about, we have room for that. And if you do your thing correct as the 1 student, and then the 11 students do their thing correct as the 11 students, all 12 will arrive at the same destination. Everybody will get the same answer at the end. Of course, the extension of that analogy is that sometimes the one person in the corner might be one person that doing the correct thing as opposed to the 11 others, some of whom might be going down that road out of sheer peer pressure. They might know that what they're doing wrong, or they might sense that what they're doing wrong, but because of peer pressure, they're not brave enough to do the thing differently. And that is one of the things I wanted to develop as somebody who learn maths. That is why I'm trying to break it down so that you develop a certain amount of confidence in your own knowledge and application of the fundamentals. So even if everybody else in the room doing it wrong, you could stick with it and be confident that you will come out with the correct answer. Right? Maths is life, you know, and life is maths. Yeah? So let me take the 3 as the first now. Right? So we take out the 3. So you say, let me give my orange marker a little run out manual. Let's see. You take out the 3. Let me say somebody in class realize that 3 by 14 is 42. It happens like that. Right? They say 3 into minus 2y squared plus 14y. Right? No problem. You see 2 and you see 14. So you know immediately that you know immediately that the next, minus another question, the next variable is 7. No problem. So you have 3 here, by 7 here, by 2, sorry, my mistake. 2 is the next variable, not 7. I think more the 7 and 5 there. 2, right? 2 into minus 2y squared is y squared, minus y squared. 2 into 14y is plus 7y, right? So 3 by 2 is 6. 6 by minus y squared plus 7y. And then you realize y, so you take out the y. 6y into minus y squared plus 7. Sorry, minus y plus 7. And you realize, well, alright, we got to do something about that minus sign. So you take out the minus sign, minus 6y into minus, divided, minus into minus is plus, minus into plus is minus. Boom. Minus 6y into y minus 7. So you could take out the 2 first, you could take out the 3 first, you could take out the 6 first. Doesn't make a difference. Right? Or you could take out the minus 1 first. Okay, let me say, again, another person in another corner of the class might say, but sir, I decide that I want to take out the minus sign first. Well, who's saying you can't do that? In fact, that might be a very good strategy. So you get the minus sign out of the way first up, and then everything else after that is just your regular numbers, because you don't have to worry about the minus sign at that point. So you can say, well, all right, let me take out the minus sign now. No problem. So you say that is the same thing as minus 1. Let me leave it as minus 1. Minus 1 into, minus 1 into 6y squared. Remember the signs will change. Minus 42y. Right? 6y squared minus 42y is a much more straightforward proposition than minus 6y squared plus 42y. So by removing the minus sign from the get-go, you put yourself in a position where you could now focus on just the regular maths without the headache of, all right, that minus sign, boy. What we do with that minus sign? When to engage the minus sign? You take the minus sign out of the picture early. So minus into 6y squared minus 42y, and that would then be minus 1 by 6 into y squared minus 7. So guess now, Bram, minus 6. Well, we have these y still, minus 6, y squared minus 7y. So minus 6 by y, minus 6y, into y minus 7. So we just did one question in, we took out the 2, we took out the 3, we took out the 6, and we took out the minus 1. We did this in 4 different ways. This one question here. That, ladies and gentlemen, is why my videos could be so long. Because I've taken the time to illustrate the plethora of options that you sometimes have in a mathematics question. So what's the meaning of the word plethora? You know, in my session we just deal up with the vocabulary too, because maths have plenty of vocabulary in it, you know. Maths is language and language is maths. So let's say there. Boom. So the word plethora, P-L-E-T-H-O-R-A. You would hear people saying that plethora, listen now man, plethora is one of those words where you hear a politician use it on TV and then other people will just want to use it just for fun, just for style. Sometimes they just want to use it to impress somebody else. But if you know the meaning of the word and you know how to use it, man, you could use it. And you could use it fluently. You could just talk about a plethora of this and a plethora of that. So yes, in maths, with the factorization questions, sometimes you have a plethora of different ways in which you could work the question. We just work one question in 4 different ways there. So plethora, P-L-E-T-H-O-R-A. What let's say there? Plethora, P-L-E-T-H-O-R-A. Boom. What's a plethora? A plethora is a large or excessive amount of something. That's all. And by the way we use it, you know that's what it means. Right? So you don't need to go to the dictionary to figure out that that's what it was. But we went to the dictionary still. A large or excessive amount of something. A plethora of this and a plethora of that. In this case, we talk about a plethora of ways in which we could work one. Yeah, that's been able to lift weights. In which we could work one singular mathematics question. Right, so this brings us now to the last. I wanted to give all our next piece of vocabulary here, boy. You want to say it? Let me check it out first before I say it. All they can't say, all they don't get anything good here now. All they getting it real good. Yeah? Plethora. That was plethora. Let me see the word I'm trying to use here, boy. Vocabulary. It's serious, you know? Papa, yo, mama. What are you saying there? Right. So, we are on the last permutation of all the different situations in my first salvo where the factorization videos are concerned. Right? What's a permutation? Well, let me write it down first. Permutation. P-E-R-M-U-T-A-T-I-O-N. Right? A permutation, according to Google, I need to get a proper dictionary in where I could just pick it up. Yeah. I like the idea of just picking up a dictionary instead of going from a phone all the time. You understand what I'm saying? A permutation is each of several possible ways in which a set or number of things can be ordered or arranged. Right? So we talk about arranging something. And in mathematics, there's a specific topic called permutations. That is not for this video, but on the Google we have a mathematical definition, which is that a permutation is the action of changing the arrangement, especially the linear order, of a set of items. So anytime you're changing the manner in which something is arranged, that is referred to as changing the permutation. Right? So you learn a word there. All I say. So this is the last permutation that we're dealing with in my videos here. Right? Nice. So this is now minus 9y squared minus 63y. Right. So you have minus minus, right? You have the 9, you have the 63, you see that, bram. You have a y squared here and a y, bram, you have a minus and a minus, bram. So in other words, we go back to the foundations which I throw at my students at every level when I tell them that simple observation is the first law of the mathematical jungle. Before you start to add, before you start to divide, before you start to subtract, before you start to multiply, before you start to find squares and square roots, before you start to find logs and indices and all of them things, before you start to change from degrees to radians, before you differentiate and before you integrate, the first thing you need to do is look. Observe. You know that poem we used to say in school a long time where they talk about look before you leap? It's the same thing in maths. You get a question, you have to look at the question first. Observe it. The physical question itself will tell a story. Bram, you have a whole story there. And if the question is a worded question, you read the question. That tells its own story too. Sometimes you might need to do it twice, sometimes 3 times. And yeah, get a sense of the story being told by the expression or by the worded question as the case might be. And then you start to look at formulating your attack in terms of how you're going to solve the thing. And again, there is life principles, right? One of the many ways in which you approach the mathematics could serve you in other areas in life. The whole question of observing a question, observing a situation, figuring out what it is, and then planning your attack. That is what it's about, man. Right? So yes, 9y squared minus 63y. No problem. So let me start where we left off in the last question, because I want to present that as a very valid option. So you look at the question and you realize, well, we have a minus here and a minus here. And you realize on top of that, that you have a minus sign in front of the first term. So you say, well, all right, no problem. What are we going to do? We need to take the minus sign out. That's an option. We could take the minus sign out as the first step, so that it then frees us to just run through the rest as regular positive integers, or as integers where we don't have to worry about any negative sign coming down the road. So you say, all right, no problem, there we go. So you take out the minus, you have your brackets, you take out the minus, let me put it as minus 1 to drive home the point. Usually, how we write it in maths, we would say that minus 9 squared minus 63y is the same thing as minus into 9y squared plus 63y. So in other words, the 1 there is understood. That is minus as opposed to minus 9. If we had said, all right, minus 9 into y squared plus 7y, yeah, right? The only difference between minus 9 here and minus here is that the 1 is understood. Look at right here, I'm putting it there just for the sake of instruction. But understand that as you get deeper into the maths, you need to get familiar with just putting a minus sign and knowing that that minus sign actually means minus 1. Yeah? Right, so we're going again. So minus 1 into what? 9y squared plus 63y. Alright, no problem. You see how nice it gets now? With the minus 1 out of the way, suddenly we have an expression in here with only positive signs. And we can breathe a little easier and just run through the thing. So you see 9y squared and you see 63y and I say, Let me say you see the y first. So in other words, you're not too sure about the numbers, but you see the y squared and you see the y. So you say, let me go with the y. Right? So you say, alright. So minus 1, we put that in brackets by y. Take out the y. Y into 9y squared is 9y. Y into 63y is 63. No problem. Right? Right. 9y and that's 63. Now we have different ways of looking at it. You could take out the 3 first, or you could take out the 9 first. Let me do both, just for the sake of explanation. So let me say you realize 9 here and you realize 63 here, and you're really sure if 9 is a factor of 63. But you're sure about the 3, because 3 and 3 is 9, and you see a 6 and a 3 here, no problem. Right? So you say minus by y is minus y, and you take out the 3. So you have minus y in brackets by 3. 3 into 9y is 3y. 3 into 63 is 21. 3y and 21, you still have a 3. So you take out the 3 again. So minus y, right, by 3. We are multiplying everything yet, right? 3 into 3y is y. 3 into 21 is 7. Alright? Now you can multiply and say minus y by 3. That's minus 9y. That's equal to minus 9y into y plus 7. Yeah? Or, at this point here, your next move could simply have been 9y plus 63. 9 into 63 is 7. So knowing your 9 timetables and your 7 timetables will definitely help you to run through the question faster here. But even if that is not the case, you have a slightly longer option, and that is okay too. Yeah? So minus 1 by y. So that will give you minus y by 9. 9 into 9y is y. 9 to 63. 9 into 63 is 7. So you end up with minus 9y into y plus 7. In fact, let me just write it down, because I know some people will just decide to deliberately be difficult. Right? They will see what I do and they just decide to be difficult. So here we're going to do. So we have the same line here, right? Minus 1 by y. We don't need a bracket here. We need a bracket for the minus 1. That is what we need. Minus 1 by y into 9y plus 63. Right? So you have minus y by 9. 9 to 9y is y. 9 to 63 is 7. Right? Minus 9y into y plus 7. Boom! End of discussion. Right? And of course, so we did the 3 and we did the 9. And in this case, we took out the minus 1. Right? We could have taken out the 3 first and taken out the 9 first. after, and then take out the minus 1 after. So let me do it again, just for the sake of those who just like to be difficult. Right? Right? The video will be a little longer, but listen, once we make the video at a particular length, all I have no excuse again, you know. All I have no excuse again. Right, so we're going again. Right. No, wrong working back. So this was the original question here, 9y squared minus 63y. So I'll just write it out very quickly without too much talk because I already know the situation already. So we could have taken out the 2 with the 3 or the 9, right? You take out the 3. So you get 3. 3 into minus 9 is minus 3y squared minus 21y. So you see the difference between not taking out the minus sign first versus taking out the minus sign first. You have the opportunity to make a choice. You could choose to take out the minus sign here at this point, in which case you will have then minus 3 into y squared plus 21y, and you just proceed as we just discussed. Or you could choose to say, nah, I want to continue taking out stuff that I could see. And if the stuff that you could see is the 3, well, then you take out the 3 again. Right? So you take out the 3. So you then have 3 by 3 into minus y squared minus 7y. Right? Now you could take out the minus 1, and then you still have the y. So you take out the minus 1, you have minus 9 into, remember it's minus 1 here, into y squared plus 7y. And then you take out the y, minus 9y into y plus 7. No problem. Right? So this is what happened when we took out the 3. Or you could just take out the 9 as we discussed previously. So your first move here would be minus 9y squared. Right, nobody same question here. You take out the 9. So you say 9 into minus y squared minus 7y, no problem. And then you take out the minus 1, minus 9. The signs will change here. Y squared plus 7y. And then you take out the y, minus 9y into y plus 7. Right? End of discussion. Right. So that, ladies and gentlemen, is the first installment in this series on factorization. You see the length of this video, and this is just the first video. I trust that you understand that some things in life you just have to give it a certain amount of time. There's no way to get around that. Alright, so let me take it from there and then we go on. Alright, so let's take care, keep good. Look out for the next set of videos on factorization.